Alright, so to find the slope of car A, pick 2 points that are on car A, and just be careful when you pick these that the points you're picking are right at an intersection or right through a corner of a box. Alright, so for here, my vertical change is going to be 520 miles, and then my horizontal change is going to be 1, 2, 3, 4, 5, 6, 7 hours. So I got 520 over 7. And then for car B, which is our black line, I'm going to choose 0, 0, and ooh, that's a good one right there. Alright, so for that, we have a vertical change of 65, 130, 195, 260, all the way up to 455, and then over 9 hours. Okay, now divide those and round them to the nearest tenth. So we divided those out and rounded to the nearest tenth, and we get 74.3 miles per hour for car A and 50.6 miles per hour for car B. Alright, describe in words the movement of the car that is represented by the following graph. So we're going to use this graph and choose which one of these 4 scenarios matches the graph. Alright, so if we look at what's going on here, we've got a car traveling for about 2 hours. Then it's not picking up any distance. So the car is effectively stopped right here because the distance isn't increasing. And then the car is driving for another 3 hours. So it drove for 2 hours, stopped for an hour, and then drove for 3 hours. Now, if we were going to estimate the rate of change for this first 2-hour drive, okay, we need to estimate what the coordinates of this point are. And we can use this point. Alright, so if this is 60 and that's 120, 90 would be halfway between those two because there's a difference of 60. So if 90 is about halfway between these two, I'm going to guess that's about maybe 100. And it traveled for 2 hours. So we'll, instead of making that 95, let's say that's about 100. Okay, miles in 2 hours. So that's 50 miles per hour. Alright, so the car moves with a speed of about 67 for 2 hours. No. Car moves at a speed for about 50 miles for 2 hours. Possible. Car moves, the speed of the car increases continuously for 2 hours. Okay, that is false because the slope is constant, so the speed is constant. All right, the only thing that would show you that the speed was increasing would be if the line was curved. Then you'd have accelerating speed. Here the slope is the same, so the speed is constant. There is not an continual increase in speed. Okay, the car moves with a speed of about 50 miles per hour for 2 hours. So both looks like B and D are still in play. All right, then it halts for 1 hour, and then continues its journey at 50 miles per hour for the next 3 hours, or 67 miles per hour for the next 3 hours. So you could say, if you said it was 50 miles per hour, then basically the slopes of these two lines would be the same. All right? So you can kind of just estimate that. If I take the slope, if I take this line and get its slope, line it up with the first line, so from that, I know the slope of this first line we said was about 50 miles per hour. And you can see that the red line and this black line are not parallel. So that means that this is not going to be 50 miles per hour because it has a different slope. Okay, it's a bit steeper, which would make sense that it's probably going to be our choice B, because this speed is a little bit greater than 50. Now we can go ahead and calculate the speed for the black line to kind of verify what our gut's telling us here. So I chose this point. I used 3 100 because we thought this height was 100, or this distance. And then this point up here at 6 300, calculated the slope and got what we thought was true, 67 miles per hour. So we'd say our choice here is B. The table lists the average monthly costs to workers for family health insurance for various years. Use a graphing calculator to fit a regression line to the data. So to do that on your TI-84, press the Stat key, choose Edit, and in List 1 you're going to put the value of how many years since 2009. So you don't type in 2009, you type in 0 for 2009. 1 represents 1 year after that, and so on. So we'll type those in for our List 1. And then we go over here, just use your arrow keys, go over to List 2 and put in the cost of insurance, the average monthly cost for insurance. Alright, my two lists are filled in, so double check, make sure you typed in the numbers correctly. Now we're going to go back to Stat, and we're going to go over one menu to calculate, and we want to go down to linear regression, which is number 4. Hit enter, and we want it to use List 1 as the X, List 2. Okay, we're not going to worry about storing the regression equation, so you can skip that, and then highlight Calculate and push Enter. Alright, now what it does is it gives you the equation that fits that data. Okay, so this would be 20.257x plus 305.523, and it says round it to the nearest hundredth. So we're going to look at the 7 and the 3 and round our answer. So we would go 20.26x plus 305.52. And that is our equation. And then you're asked to answer this question. This value is blank dollars, and then you'll have a drop down menu of more than or less than. So we can see that this is greater than, and we want to know how much it is greater than. So now we take these two amounts and subtract them. So we end up with $25.15 more than the $482.97. Now, when it asks for the correlation coefficient, that is the value here that is R. The closer this is to 1 or -1, the better the fit of the line. So a correlation coefficient of 0.98 is pretty good. That's the R value here. So I typed that in to 3 places, the nearest thousandths. And then, does the regression line fit the data closely? Yes. So yes, the line fits the data closely. The correlation coefficient is close to -1. No, it's close to 1. All right, find the equation of a line defined by y1 that yields the table of data. All right, give the equation in slope-intercept form. All right, since you're told that this is a line, we can pick any 2 points to determine the slope. So it doesn't matter which points I pick. Okay, I can look at this list of data. Let's say I take -10, -34 is 1 point, and then -8, -24 is my second point. Okay, so to put this into slope-intercept form, I'm going to first calculate my slope. So I chose 2 points because I'm told that this is a line. So it doesn't matter which 2 points I use. I calculated my slope, and I got 5 for the slope. And I chose these 2 points. Once I got the slope, I put the slope into y equals mx plus b. And then I chose a third point, so -6, -14, and I substituted that in for x and y, and then I solved the equation for b, and I got 16. So my overall equation is 5x plus 16. And then you type that in. Okay, the graph shows the percentage of a country's adults on weight loss diets. Use the 2 points whose coordinates are shown to find the point slope form of the equation of the line that models the percentage of adults on diets X years after 1987. All right. We found the slope by taking these 2 points and plugging them into our slope formula, this being x2, y2, x1, y1, and we got a slope of -1/4. So then I come over here to my formula, and I have y minus y1 equals -1/4 x minus x1. Then I choose one of these 2 points, it doesn't matter which one, and I plug it in for x1 and y1. So I'm going to choose the 12, 13. So I take those coordinates, and that's going to go in for x1, and that'll go in for y1. So I'd have -13 equals negative 1/4 x minus 12. And then I stop there because now it is in point slope form right here. All right, the next part of this question is to take this form and convert it into slope-intercept form. And that's easy. All I do is multiply it out and then get every y on one side and all the other numbers on the other. So I'm going to distribute. I get negative 1/4 x. Okay, and then I'm going to have negative 1/4 times negative 12. And there's the equivalent equation in slope-intercept. Use the linear function to predict the percentage of adults on diets in the year 27. So our x value is the number of years after 1987. So 2007 is 20 years after 1987. So I'm going to let x equal 20 in my formula, and I'll get y equals negative 1/4 times 20 plus 16. So I'm going to get an answer of 11% of adults on weight loss diets in 2007. All right, our next problem here has to do with transformations. So these are asking you're just pulling these and putting them where they were with the appropriate equation. So x minus 10 quantity squared. That's inside the parentheses, so that's bizarro world. That would be a slide 10 to the right. So a translation of 10 right. Okay, the next one, I'm going to skip down here because it's in parentheses. That would be 10 left, bizarro world. All right, x squared minus 10, so that's outside the parentheses, the minus 10, so that's going to be a translation 10 units down. And plus 10 would be a translation 10 units up. And then times 10 is a vertical stretch by a factor of 10. We're going to take the point 614 and apply this transformation. So adding 3 inside the parentheses means that we're going to slide the x-coordinate 3 places left. And I would do that by subtracting 3. The y-coordinate is unchanged. So 314. The second one, I'm going to take 614, but now I'm adding 3 and it's outside the parentheses, so that's going to be a vertical slide, 3 up. So I'm going to add 3 to my x-coordinate, or excuse me, my y-coordinate, and there's my new coordinates. So here we're multiplying inside the parentheses. So this is Bizarro World. So instead of multiplying by 2, you're actually going to divide by 2. So that's going to be a horizontal compression. Instead of multiplying by 1/2, you're going to divide by 1/2, which is the same as multiplying by 2. And that would be a horizontal stretch. All right, so we've got a function on here, and we want to take it and turn it into a new function, g of x, by taking the old function and multiplying its input by 2. So this is Bizarro World. So what we're going to actually end up doing is taking the x coordinates and dividing them by 2. So we'll have what is known as a horizontal squeeze. So what will happen is this x coordinate of, like I've got a point that's at -16, 0. Divide that by 2, the new point is going to be at -8, 0. All right, this point, let's see, if that's 16, looks like we're counting by 4s. So this is the point -8, -8, and that point, if I divide by 2, would be -4, -8. So that's going to move, that point will move in here, and my box is that this edge of the box is going to look like that. All right, and I can see I don't really need to go any further because that'll be, I've confirmed that part, and that's the only one that matches, so my choice is B. All right, this last section is you're taking this original graph and you're finding out it's different, these different graphs from it. So the first one is take f of x and 2 plus 2. So that simply means we're going to take this graph and everything is going to move up 2 places because that's sliding 2 up. All right, so if we look at our graphs here, whoops, I missed the point right there. This should be 2 up. And that matches C. All right, our next choice will be to take our graph and move it 4 places to the left. So this is 4 left. So each one of these dots is going to move 4 places to our left. C is, the negative is on the outside, so that is we're going to flip it over the x-axis. Our figure will look something like that, which is B. Oh. D, I mean, sorry. All right. Next one is 1 left, 3 down. So 1 left, 3 down, 1 left, 1, 2, 1 left, 1, 2, 3 down. All right, the next is a vertical squeeze. So I take each y coordinate times 1/2. Okay, it becomes half the distance to the x-axis that it used to be. So what that would happen here, this point right here is at a distance it's at 0, 2. So when I take the y coordinate and multiply it by 1/2, it becomes 0, 1. So it's half the distance closer than it used to be. Now this has a y coordinate of 0, so when I multiply it by 1/2, it doesn't change. It stays on the x-axis. Okay, this has a y coordinate of -2, an x coordinate of 4. So when I multiply that by the y coordinate by 1/2, I get -1. So that is a vertical squeeze. When the negative is on the inside of parentheses, now we're going to flip it over the y-axis. And there's our point.